Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello and welcome to another Robotics and Automation News interview. My name is Abdul Montakim. I'm editor of the website. This interview is with Judson Kauffman, the CEO and co-founder of a startup called Terradepth. Terradepth has built an autonomous underwater vessel, or an AUV, designed to help map the world's ocean floors.
My name's Judson Kauffman. I'm co-founder and co-CEO at Terradepth, and we are building a global centralized ocean data and information network. And we're doing that basically through two mechanisms. One is we have innovated a new scalable deep ocean autonomous data collection system. So it's a submarine robot. It's highly intelligent and machine learning enabled. We're also taking historical data that's been collected by other folks and is siloed in different locations around the world. We're ingesting that data, we're structuring it, we're cleaning it up, and we're presenting it back to ocean data users and ocean stakeholders in a way that is very easy to use and easy to visualize and understand.
Okay, let's have a look at this website of yours and maybe carry on talking about the company. I had a look myself, and it is fascinating what you're doing. And it's obviously, a lot of people would know that the ocean floor, for example, the oceans in general, are not as well known as we might imagine them to be, given that we all are very used to things like Google Maps and Apple Maps and all these maps applications. We tend to probably think that we know the oceans and everything very well. But give us an outline of what we do know and what we don't know about the oceans of the world.
Sure, Abdul. The truth is that is painfully understated. The level of ignorance that we as a race, as the top of the food chain species, understand about our Earth. We've characterized less than 10% of our planet to high detail and resolution. And the reason for that is because most of our planet, most of our livable space, our biosphere is underwater. And the ocean is just a very difficult and very expensive place to operate. And so it's been super elusive to humans for a very, very long time. We've mapped about 10% of the sea floor to high resolution. So we're missing the vast majority of just that seafloor map, but we also have yet to develop an understanding of the water column. What does that ecosystem look like between the surface of the ocean and the sea floor? So even that is unknown. 98.5% of our biosphere is in the ocean, and we understand a tiny fraction of it.
Appreciate your you putting a number on things, and I know that there are estimates, there are best estimates, and they could be subject to revision as we go along. But it always helps people to understand things when you put numbers on them. So you're saying that we know about 10% of the ocean floor. That leaves obviously 90%, and what 10% do we know? I mean, is it around the shores of the US and North America and other, land masses, Eurasia, or what is it what's the 10%? And what are the most interesting parts of the ocean floor for you personally? What would you like to map with the, we'll get onto the robot and talk about the technology in a little while, but just as a, average person, what kind of things about the ocean floor interest or fascinate you?
Sure, I'll answer the first part. What do we know about the ocean, and where is that 10%? Most of it is wherever you can find hydrocarbons near near shore, right? So where have the oil companies invested in researching and understanding what's out there, right? Because it's such an expensive endeavor, very few commercial entities have even tried to go explore areas of the ocean. Even powerful sovereign navies are pretty limited by cost when it comes to mapping. You know, for example, you'd think the United States would, for strategic purposes, we would have mapped our coastline, but we've only mapped 10% of our own coastline. So the 10% globally that humans do understand are primarily very sensitive ports and harbors that belong to wealthy nations who care about the sensitive infrastructure in those ports and harbors from a defense perspective, and also wherever there's natural resources that are near shore. And mostly these are shallower depths, again, because cost is such a limiting factor. So I talk about oil because that's where most of the data has been collected, is by these oil and gas companies. But I don't want to send the message that that's what Terradepth is out to do. We are not here to make oil and gas folks make their jobs easier. We're here to democratize ocean data. We want everyone in the world to be able to log in to a very easy to use website like Google Earth and virtually explore the ocean with a high level of detail and highly accurate objects of interest and areas of interest. We want folks to be able to understand what the water chemistry is in a given area at a given time of the year versus what it was maybe last year. What's the biology? How's the biology changing in this area? Temperature, salinity. What sort of environmental DNA exists here? What does the seafloor look like? You know, what shipwrecks are out there? No one's ever been able to afford to go and look for all of these shipwrecks. It's just too expensive. So they do is they wait until they've got a high degree of confidence from secondary research or primary research, and then they spend, you know, $100,000 or $200,000 a day on a ship to go take a closer look. And most of the time, they miss. There's nothing there.
Yeah, it's a well, first of all, it's interesting that it's brilliant that companies like yours are going to do this, but it intrigues me that it hasn't happened before. I wonder why. I mean, as you say, this kind of the kind of exploration or adventure that you were referring to. I can imagine it's very, very expensive. You've already put a number on it, and yeah, it's intriguing that it hasn't happened before. This kind of company and technology hasn't emerged before. Let's talk about the company. It's called Terradepth. Tell us a little bit of an overview and about your submersible machine. And I'll try and find bits of the website that are relevant. So we've got Jellyfish here to begin with, and yeah, go on. Tell us about the company and the technology.
Sure. I think it may be good to start this with kind of answering your first comments, or responding to your first comment about why hasn't anyone done this before, because that sort of leads into the story of the company. Because it really started with that same question that you asked, is why hasn't someone else done this yet? Why hasn't someone else figured out a way to scale ocean data collection, bring that cost down, so that now we can start to illuminate ourselves with respect to what's going on down there? And the reason is technology has been too limiting until about the last 10 years with developments in machine learning and robotics and autonomy. Prior to that, it was a very manual process. You had to take a ship out there with some sort of a sensor array that you could drop into the water from the ship. But the humans had to lower that thing down. And over time, remote controlled systems were developed, but still, those only had a few hours of battery life, and they didn't have any automation. They couldn't understand what they were seeing. And so they're collecting so much data that in a short period of time, the human beings up on the surface, they've got to pull all those sensors back out of the water, take that data off, and then put that into their computer and start looking at it and say, well, what's down there? And that's an extremely time-consuming operation, as you can imagine, because you can't see what you're looking for until after the fact. And even then, it takes a long time. So it takes at least twice as long to find what you're looking for as it did just to go on the hunt. So, and you're spending money on this ship, which has a crew plus the scientists that are there. It's too expensive. And so that's the reason nobody had done it before. But the reason that nobody did it, in the last 10 years prior to Terradepth, we think there just wasn't a huge demand signal for it. So, offshore resource companies, for example, oil and gas, and the US military, other big militaries, they're the ones who are spending money in the industry. And so you think about a startup. What's a startup here to do? A startup's here to make money. If you want to start a company and go and compete with these massive hydrographic surveyors who have these huge contracts with oil and gas in one of the most expensive industries you could imagine, no one's going to give you money, right? It's going to take too long to build, whatever hardware you've got to build. So it wasn't an area that was attracting startups because it was too long of a time horizon to see any kind of a return. But again, we had a tight window, from the time that AI, machine learning, and robotics and automation really made this concept possible. So there were other folks looking at the problem, trying to figure out a solution. My co-founder and I sketched out an idea on a napkin for how you could achieve this sort of breakthrough in subsea autonomy. But we didn't know that our idea, which we thought was good, we didn't know that it was good. So we contacted some folks who worked at the MIT Underwater Autonomy Lab. And we said, hey, can you guys spend some time with us and just give us a buddy check? We think we got something, but you're way smarter than we are. They said, yeah, fly up here to Boston and we'll take a look at it. So we did that, and they looked at everything and they said, man, you guys, because you're looking at this industry from the outside, you've managed to find a really elegant way to do what nobody else has ever done before, which is create a concept to scale deep ocean data collection at a price that is affordable. So that meeting with those engineers at MIT gave us the confidence that we had a good enough idea that we could patent it and we could develop some pretty cool technology. But we also wanted to make sure that there was enough market there outside of oil and gas, because that wasn't something we were interested in getting the business with. We wanted to make sure there was enough market there to build a massive company. We're here to also generate some profit and, of course, potentially impact billions of lives and maybe save the planet if we're as successful as we think we can be. So we spent some months looking at the markets, and we said, look, there's a lot of potential here in the future for whoever can really own this ocean data piece and start to create analytics on top of tomes and tomes of various ocean data. So after that market study and after that meeting with those engineers, we put it all together, put a business plan together, and we went and raised some money.
So you've got to a point where you've not only raised the money, you've built a machine, and obviously you've got offices and a fully operational business now. And give us an insight, if you can, about your potential customers. I know you're saying that oil and gas may or may not be something that you do business with. Obviously, they're the obvious candidates for doing business with. But what I can't immediately think of who else would be interested in such deep data. I mean, it's fascinating. Don't get me wrong. I mean, Google Maps has been around a long time. I remember years ago they published a 3D model of the Earth without any water. All the oceans were missing, and it looked like a contorted sort of weird shape. It didn't look like a sphere. It looked like, I don't know how to explain it. It was very odd looking to see the world without oceans. That meant that they mapped the floor to some extent, mapped the floor of the ocean, the ocean depths and all that. So that was fascinating to see. I mean, but you're probably, well, you are talking about a much greater level of detail and all that. I mean, who would be interested in, everybody would be interested, but who would be interested enough to pay good money for that kind of data? What kind of businesses would they be doing themselves?
Sure. So the first that comes to mind is sovereign nations, right? So every sovereign nation owns whatever resources may be in their territorial waters, right? So that means anything that's within 200 nautical miles from their coast, whether it's a sunken ship or cobalt or gold or seaweed that can be turned into food products or wind or you name it, that belongs to that nation. But they can't take advantage of that value, obviously, until they understand what's there. And every sovereign nation in the world that's got significant amounts of coastline understands only a teeny tiny fraction of what's there. And many of them are willing to pay a lot of money to understand what the characterization of their coasts are. So that's number one. Sovereign nations are interested in growing their economic potential. Next is offshore wind companies, right? So offshore wind is growing very rapidly. They have to conduct a survey of the underwater environment before they can do any construction. And then once they build a wind farm, they have to do regular inspections to make sure there aren't any problems, make sure if there's any organisms that have moved in, that they're being protected and cared for. The next, another massive industry that people don't tend to think about is underwater cables. So fiber optic cables that connect, nation to nation at the bottom of the seafloor. Most of daily communication in the world happens through subsea cables, not through satellite and not through RF radio frequency. I think 92% of it happens through these subsea fiber optic cables. And the reason for that is it's just so much faster than everything else. And so we're adding more cables all the time. So those customers are companies like Facebook or AT&T or Google.
Yeah, it's very, very, well, now that you mention it, it seems very logical and kind of almost obvious, but not being in this business and this business being, your business being, very new and pioneering in many ways. It's, when somebody tells you a good idea, one of your first thoughts is, oh, that's so obvious. But yeah, obviously this takes some doing, some achievement to get to this point. Tell us about the machine that you've built, this subsea, can it be called a submarine or what's it called? What's the name for this kind of vessel?
Typically, the word submarine is reserved for vehicles that have humans on board, but a lot of people call this a submarine, and we don't get upset. But you could call it a drone. You could call it an AUV, which is autonomous underwater vehicle. That's probably the most common term. You could just call it an ocean robot. It doesn't matter. Any of those things work. But yeah, so we built our prototype to prove out our breakthroughs in subsea autonomy. So with the money that we raised in our seed round, we were able to build the software platform that I mentioned earlier, which is this cloud-based ocean data portal where we take our data plus everyone else's data, we structure it, we sort of unify it, and then it goes out to users. It works much like Google Earth or any modern piece of geospatial interaction software. But we also built this hardware because even if you have the best ocean data visualization tool in the world, it doesn't do you much good if you haven't collected all the data, right? It's like when Google Earth was getting off the ground, it wasn't going to be sufficient for them to launch just with Northern California. Who cares? Like, show me the world. So we have to find a way to get all that data. So that's what we've done with this piece of hardware. We've basically built we started with kind of a standard autonomous underwater vehicle. we gave it a lot of machine learning capability and computer processing power, so that when it sees something underwater, even if it's at 6,000 meters, it can identify that object or that anomaly, and make a decision based off of that identification. So it can decide if it needs to turn around, gather more data, if it needs to come to the surface and contact a human as soon as possible, if it needs to turn on additional sensors to gather additional types of data, whatever. So we've put that decision-making capability on this robot. That hasn't been done before. And we've also given it the ability to recharge its own batteries at sea fully autonomously. So the whole approach here was, how do we remove the requirement to have a surface ship with a big crew on it, because that's the main cost driver. And so we've removed that requirement, and we've put all that functionality that the ship was providing. We've put it now autonomously on our AUVs.
Okay, so tell us about the sensors on this AUV or submarine. Like, I mean, sonar is a traditional historical thing. As far as I understand, it uses some sort of sound wave that it emits and then reads what bounces back. But you know, in the automotive trade nowadays, with the autonomous vehicles, especially LiDAR is very much talked about and used. Obviously, we all know CCD chips in cameras that capture, you know, various colors and images and photographs and all that. Tell us about some of the, without getting too in depth about the technology, give us a high level overview of what kind of sensors it uses and what kind of images or data it collects using those sensors.
Sure. So we wanted to build a system that could collect very high resolution data. There's a lot of efforts going on in the world to collect ocean data from the surface of the water, sending sound waves all the way through the water column. And that's much cheaper. You can just use a boat, and you can use an autonomous boat. The problem is those signals are traveling very far through seawater, right? So the signals are getting mixed up and attenuated to a pretty high degree. So by the time that those signals are returned back to the receiver, you've got kind of low grade, low resolution data. So there may be a sunken ship down there, and you can miss it completely, even if it's the size of the Titanic. So there's a lot of low resolution efforts to map the seafloor, but we didn't think that was sufficient. We wanted to be able to find small items. And to do that, we've got to get down into the environment and get very close to the seafloor. So we have a very high power budget on this robot, meaning we can power a lot of different sensors at one time. And the sensor payload is modular. And also I should note that we don't make any sensors. All the sensors that we're using are off the shelf. And as newer, better sensors come on board, we'll phase out whatever we were using and put the newer one on. But we have a couple of different types of sonar so that we can get different types of images. We also have a still camera and video camera with infrared, because once you get below the photic zone, obviously there's no light in the ocean, so you have to be able to illuminate the object with infrared. We've got chemical sensors to understand things like pH and alkalinity and salinity. There are some fascinating environmental DNA sensors. There have been developed by other companies. We haven't put them on yet, but that's our intent, so that we can understand, you know, what sort of biomarkers and other environmental DNA may have been in that water area previously. And of course, our navigation suite, which is pretty robust, because we have to know exactly where the item or the object is when we find it. So our resolution is less than a meter of clarity, and our navigational accuracy is also less than 1 meter.
Sorry, what does that mean? Less than 1 meter? I don't understand what that means. Sorry.
Sure. So the whole ocean has been mapped today, right? The whole seafloor has been mapped, but at a resolution of, I think, 50 kilometers, which means if Manhattan were at the bottom of the ocean, we wouldn't know it based on the maps that we have today, even though you could say we've mapped 100% of the ocean. Yeah, you have, but at a 50-kilometer resolution. So anything that's
Oh,
50
I see.
kilometers or smaller may have been totally missed by your mapping sensors. So we're at 1 meter. So it just means that if there's an object that's, you know, a half a meter in size, we will identify it, and it'll be clear to the human eye once we convert that sonar image to a visualized image.
Yeah, okay, thanks for that. Also, a couple of little things I may have missed. You said it recharges itself. How does it do that? Is it solar or some sort of, I don't know, hydro sort of, how does it recharge itself?
I wish it was solar. Unfortunately, solar is still too inefficient. We would need too much surface area to make this system work. We are using a generator, and we have a patent to use diesel electric or hydrogen fuel cell. So when the robot is underwater collecting data, it's operating on battery power. We use lithium-ion batteries right now. And when those batteries run low on energy, the robot recognizes that, and it comes to the surface of the ocean so that it can breathe air. And once it can breathe air, then it can turn on that generator. And once the generator is turned on, it starts to recharge those batteries.
Excellent. And the other little gap I may have missed, what are the depths that it can go to? I think you mentioned 5,000 meters, but what's the maximum depth it can go down to? And what's the maximum depth a human would be safe to go down to, because the pressure is so great at a certain level? What are those numbers? I don't know if you know them off the top of your head.
Yeah, so our system can go to 6,000 meters, which is known as full ocean depth. So 6,000 meters gets you about 98% of the whole ocean. There are some very deep trenches that go much deeper than that, but they're going to be inaccessible to Terradepth. But we thought, hey, 98% is good enough. Human freedivers, I think the world record holders are close to 200 meters, maybe 150 meters. Is about as deep as we can go, but there's some fascinating biological adaptations that occur when we dive to those depths that are pretty fascinating. But that's another conversation.
Yeah, I can imagine. Yeah. Well, all right. Well, this is a terrific piece of kit. It's something that I, love to keep track of in terms of what happens and what data you collect. And I don't know how much of it is going to be made public. Some of the environmental work that you may do, work that you may or may not do in the future for environmental organizations may become public, whereas the sovereign nations and other kind of commercial data probably wouldn't be made public. How many of these units do you envisage needing over the next few years? I don't know if you've got business projections or if you have a series production in mind anyway. What kind of numbers of unit numbers are you looking at over the next year or two?
Around 30 of these systems over the next year or two, but ultimately we'd like to see thousands of these spread across the globe, persistently collecting data, because weather patterns do occur on a daily basis in the ocean, and weather patterns change things. And it's important to know what's happening. So we'd like to have persistent presence within the next decade.
Yeah, I think there'd be quite a lot of these autonomous vehicles of various sizes and shapes. Actually, about the size, obviously it's difficult to gauge the length of this. What's the length of this? Difficult to say from the picture. I mean, unless you compare it to this fish, which means it's, I don't know, actually, I don't know what kind, that might be a massive fish. Yeah, what's the length of this thing?
9 meters.
9 meters, right. Yeah, it's quite a significant size.
Yes,
Do you envisage needing or developing smaller or less? I don't know, 9 meters. I don't know if I'm surprised or not, but yeah, it seems like a good size. I don't know.
it's
Is
big.
there a
Yeah,
particular
it's big.
reason for it to be that length? Does it need all of that for the equipment inside? Obviously, it must do.
It does. Yeah, most of that space is really for energy.
Uh-huh.
Uh, you know, our computers are super small. Even once we put them into a pressure vessel, they don't take up much space.
Uh-huh.
So really, it's batteries. We want to be able to power a lot of sensors, um, because there's a lot of different types of data that are valuable. And so we said, okay, let's avoid making multiple passes through a single location with different sensors. Let's put all the sensors through there, in one pass if we can. So most of the space is batteries, and the generator.
Yeah, that's the big technical challenge, isn't it? The batteries, and for electric vehicles, that's the big competition between companies who can develop the most longest lasting. But same with smartphones, I suppose. Who can build the smallest, most durable or longest lasting battery.
Yeah.
And that may affect your design going forward. I don't know, but yeah, it makes sense that, I mean, rockets that go in space, majority of the space is for the space within the rocket or the vessel itself is for the energy, the fuel and things like that. So
Hmm.
that makes perfect sense. So yeah, so how long have you, tell us about the company in terms of its, the business side of it, in terms of how much you've raised and how long you've been in operation. Do you have other funding rounds coming up or anything like that? And what's your, tell us about the business side of it.
Sure.
Of Terradepth.
So we raised $10 million in our seed round. Most of that came from a corporation called Seagate Technologies. Seagate manufactures hard drives and data storage devices.
Yeah,
So,
I saw that logo on the website. I've actually got a
mhm.
Seagate hard drive, and I guess most people have on their desk somewhere. They got a Seagate drive, so that's great. The good partner to have, I imagine.
Yeah, they're great, and they have some really brilliant engineers and physicists in their company, and we're able to tap into a lot of that power. So they're a great partner for us. And there were some private investors that came in as well. Um, for various reasons. Some of them for environmental reasons. They want to save the planet and want to ultimately find new pharmaceuticals and new medicines, which will come from ocean organisms. Um, and we are closing another funding round in the next couple of weeks. So we'll be announcing that very soon.
And are you allowed to say how much you're expecting to raise in that funding round?
Uh, I'm not sure yet. As much as we can is the short answer.
Yeah, and the other thing, I don't know if you can be specific, but without being specific, are there any kind of like confidential or secret projects that you've got? I mean, I'm not necessarily thinking military. I mean, there are. I think I saw a company or the German, some sort of German authority or government-backed agencies trying to figure out how to get fuel out of certain plants or, oh yeah, rare earth minerals, because we're also heavily dependent on China for rare earth elements. The Germans are looking at certain types of seabed materials. I can't remember, it's some sort of plant or coral or something that it's looking at. It needs to be processed through a lab after it's brought out of the ocean. But are there projects like that are confidential or secret that you are doing now, or maybe you will do in the future? You can envisage doing things like that. or is it all open projects that within reason they'll be, they're fairly standard projects, if you like?
Yeah, we aren't doing anything the real secret. Mostly standard stuff. We did have a fascinating conversation with a team from NASA who's interested in mining lunar ice. And so there's ice on the moon, and ultimately, humanity would like to have a permanent presence on the moon. And NASA's looking at how do we do that. And one of the key things that we're going to need is water source. So because there's ice on the moon, the idea is, well, can we take the ice that's already there, process that into drinking water so that humans who are living up there have something to drink? So they wanted to talk to Terradepth because NASA doesn't have a lot of experience developing systems that can operate with full autonomy in an environment that is totally bandwidth constrained. One of the things that makes Terradepth or underwater technology more difficult than space technology is the fact that you can't communicate with underwater systems like you can systems even on orbiting Jupiter or on the surface of Mars, right? You can still communicate with those systems via satellite. So NASA is going to be sending robots underground to mine this ice. And we talked to them about how our autonomy computer and our payload management autonomy computer could help them achieve that mission.
That's absolutely fascinating. I've got a couple of things for you before I let you go. I know I've taken up a lot of your time and I really appreciate it. A couple of things. One is, before I forget, I'll mention both of them. One is I'm fascinated by all these underwater monuments that, ancient structures that are being found all over the world. And the other is underwater, under the shell, under the ice of the polar regions, Arctic and Antarctic regions. I mean, that's a surely fascinating project. I don't know who would pay for that sort of thing, but your submarine seems perfect for that kind of job. I mean, there's no way they can send human manned or crewed submarines under there unless they're Russians and they're used to very, very cold, and they probably are in many parts of the Arctic region. But in terms of exploration, I imagine that's potentially a market for you. There are scientific bases in Antarctica and probably in the Arctic as well. So they may be able to bring together the cash to do that. But yeah, I thought I'd mention them before I forget. I have a habit of forgetting. Let's deal with the, I'm fascinated by the underwater monuments that have been found in many different countries off the coast, maybe 10, 15, 20, 30 meters, not too far into the water. India is one place, Japan is another, Mediterranean. They found these places, things all over the place. I don't know if you follow that or are interested in that kind of thing, but I've seen them on YouTube myself. I mean, what do you think of all that? And I don't know if it's a commercial thing for you, but what's your view on those things? What do you know and what do you think of them?
Yeah, I don't know much about them. I think it's fascinating. We have 300,000 years of human history on this planet. The Earth has changed a lot in that period of time. So there's untold buried cities, buried treasures, buried monuments. Who knows what? It could be anywhere in the ocean. There's lost islands, potentially lost continents. So there's just so much that we don't know. I think the general population tends to forget or not even be aware that we don't know what's down there. I think the space race started in the 60s, sort of just distracted everyone, and we kind of glazed over the fact that, hey, we haven't even finished exploring our own ocean. Like, it's great that we're going to space, but let's put some more effort here before we put it all there.
Yeah, I've been watching YouTube videos. There's a guy, there's various guys, and probably you probably know some of them, but they've written books about these things, and the pictures about these underwater monuments are very rare and absolutely fascinating, spellbinding in a way, because they're so rare and because it's so, I mean, I don't know how to describe, or inspiring, I suppose, because the theory is that, 10,000, 11,000 years ago, the ice age ended and there was a massive flood, and human civilization was virtually wiped out. Most of them used to live on the coast, which then became submerged underwater, so it's no longer the coast anymore, it's just underwater. So there's a huge, completely different type of technology that was used, that powered a global civilization back then. That's the theory. And I must admit that in my mind anyway, there's a lot of credibility to it, but it's not accepted by mainstream science or archaeology. So it'd be really interesting to see companies like yours, take pictures and maybe add a little bit of information, if not credibility, to some of the claims about previous technologies. Because these monuments, I mean, we all know that pyramids and all those buildings, we don't know how they built such massive structures. Those kind of structures are under the water as well. So there's something, that happened before that companies like yours could help answer. And yeah, all right. Well, how about the Arctic part, or the underwater, the ice, under the ice, the Antarctic, and things like that? Similar kind of things are going on. Similar theories abound about civilizations under the ice in Antarctica, but just in terms of conventional, non-weird research stations, that's a potential market for you, isn't it?
Sure, I think all of it is, at every piece of the ocean. There's something valuable to at least one group of stakeholders.
Hmm. Okay, well, I think I've taken enough of your time. I really appreciate you giving us the insights and answers today. Is there anything that you'd like to add that I didn't maybe ask about in the interview?
No, this has been great. Thank you so much.
Yeah, okay, it has been. It's fascinating. It's a great idea and a company. I hope, to hear more about it over the coming months and years. Good luck with everything, and thank you very much.
Thank you.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.